today specifically, we're going to focus on the token capabilities in Kaleido, namely the ability to use our marketplace services to create ERC20 fungibles or ERC721 non-fungibles, and then use our atomic swap service backed with an escrow smart contract to securely transfer or swap those assets amongst different participants. Once we kind of wrap our heads around that, then we're going to take a look at some really cutting edge stuff around zero knowledge proofs with Zether smart contracts and Sigma bullets. So I have a few slides just to set the table. Pretty customary for these things. If you guys have joined these in the past, you'll have seen these and these will be familiar. So, you can tune out for a few moments. But at a very high level, Kaleido, built for modern business networks, very, very industry use case agnostic, capital markets, finance, supply chain, pharmaceuticals, healthcare, NGOs, et cetera. We're not going to actually dig into the actual construction of a consortium and a blockchain or configuration today. That's something that we'll be covering on Wednesdays with our higher level 101 walkthroughs. But even as we're sort of interacting with the services, it'll be very clear that the platform itself is incredibly, incredibly simple. Everything is backed by a clean REST API. So as we run through this, everything that I'm doing inside of the console is something that you can automate and programmatically accomplish. Lastly, built very much for the enterprise. So, a robust suite of functionality around storage, around key management, around identity, privacy, et cetera. All of the cloud infrastructure and tunneling and security is baked in as first-class citizens. So high availability, disaster recovery, auto-scaling, all of that comes out of the box. So as we look at the marketplace and we look at what goes into a full solution, what we've come to realize is that the chain, while incredibly important, that's your trust anchor, and it's a small portion of the overall solution. We start to need things like we're going to look at today, the way to digitize assets and the way to securely swap those assets. Maybe even the need to extend that a step further and have completely confidential and anonymous, fungible settlements, using those zero knowledge proofs. But it goes much, much broader than that. And you need to start answering questions about data storage, what goes on chain, what goes off chain, how do we integrate with our back office processes? How is data represented on chain? Is it completely obfuscated? Do we add some metadata? Is it all in plain text? At the actual transactional layer, right? We need the ability to leverage certain node clients to accommodate private transactions. And then we need to securely consume those events to our back office processes. Moving a little higher, we start seeing the need for oracles and for applications to speak to each other. And then at the actual top level on the client side, this is where we get into these tokens, these new digital asset paradigms, and some really, really clever things around cryptography with zero knowledge proofs. So we'll touch on all of that through the demo. Super high level, some of the things Kaleido makes it very, very easy to do. Create these modern business networks, click button simplicity. Create assets of different characterizations, fungible, non-fungible, and swap those assets, expand different clouds or even run private stacks on-prem, decentralize your network with embedded governance and permissioning, and then basically the ability to plug and play, to layer on these embedded components directly into your solution. And then that last bullet point, we'll actually look at both of those today, the ZKPs and the ability to kind of do this clean new smart contract management. Super high level, you can see how basically industry and use case agnostic Kaleido is, just a snapshot of some of the customers and clients, and we see energy and retail majors, we see finance, really across the spectrum. So permissioned enterprise, Ethereum, and Kaleido basically provide you the building blocks to do a lot of really creative and clever things out there. And then I guess I've already touched on these, but running through them, objectively rated, #1 blockchain as a service platform, some really fun innovations like tethering to the mainnet or those zero knowledge proofs that we'll look at today, and then built in, SLAs, HADR. We are ISO 27K compliant, and one of a kind deployment models with multi-cloud and on-prem deployments. Okay, so that was the slides, the boring part. The first thing we're going to look at today is what we call atomic swaps. And just to kind of paint the picture for you of what we're ultimately gonna demo here, We're going to have two participants in our business network, two organizations. Call it organization ABC over here on the left and organization XYZ over here on the right. This guy's going to create, or he's going to own some fungible assets. We'll do loyalty points. And then this guy's going to own some non-fungible assets. Think of it as like a digital collectible for a sporting league. And what they want to do is they want to have the ability to securely swap these assets and not use a third party, not use some expensive or slow intermediary, or even have to trust the counterparty to, hey, when I receive that, then I'm also going to call that transfer API and I'm going to give you what I promised you. Instead, we're going to use another smart contract. We're going to use a piece of software. We're going to lock it with a secret, hence the name hash time lock contract. And this is going to provide basically an equitable framework for both of us to have a time-friendly mechanism to retrieve the counterpart's asset. One thing that's worth noting here before we dive into the actual console is these agreements in an ideal world need to be structured out of band. What you'll notice is if you have a counterpart that doesn't really agree to what you've put into the swap, those assets are going to remain locked until that contract times out. So you're not going to have that liquidity that you otherwise would have. If you do have the semantics structured out of band, then this can happen, with the snap of a finger, programmatically. All that we're really waiting on is the ability for that transaction to execute within a block. We're going to run this on Geth and proof of authority, so we'll be able to actually extract those assets within 5-second intervals. So that's my preamble to what we're going to look at. And again, please use the chat mechanism if you have any questions. I know we have at least one of our protocol engineers inside of this webinar, so he'd be happy to moderate and answer any lower level protocol layer or technical questions that you guys have. Okay, so setting the stage, what we have here is, we'll go back to the business network layer. We have a business network with 2 memberships, 2 organizations, and I've created a handful of environments. We're going to use this swaps environment to basically demonstrate that atomicity, the ability to atomically swap these assets. So each org has a node, and each org has both a token factory service and a token swap service. So what we're going to do first is we're going to create a fungible asset, and we're going to assign it to this guy's default Ethereum account on his node, and then we're going to create a non-fungible asset, and it'll be owned conversely by the default Ethereum account on his node. So we click in on a node, and we see that each node is instantiated with a default user account. We see that also here inside of the wallet, 4C0, 4C0, and the wallet is empty. There's no Ether balances, there's no token balances. We can very easily add new accounts if we want to do that here, or we can simply just use the existing account that we have at the moment, okay? So what we'll do, we'll go back here, go into the token factory, and we're going to create a fungible token and assign it to this account. So we'll call this one loyalty points. This could be an end user, a consumer that attends a lot of sporting events and NBA games, Major League Baseball games, English Premier League. We'll just call this NBA right here. We can choose the attributes for the ERC20 token, mintable, burnable, pausable, etc. And then we're going to choose an initial supply, just an arbitrary amount here. And this balance, when we deploy it, will be owned by this address right here. So create that contract. We can edit it, we can view the source code, etc., or we can just deploy it here. And this will create our first contract, our first interesting transaction inside of this environment, inside of this blockchain. Okay, so that block was mined, transaction was executed. We see the address for our loyalty points, and we see the owner. So if we go back in here, click on node number 1, click on the wallet, we see that this guy is the owner of 1,000 NBA loyalty points. Okay. So now we will go into the token factory for this guy, and we will make a non-fungible that will be owned by this address. So this will be the 721 standard. I actually should have named that one loyalty points, but we'll call this one digital collectible, and we'll give it a symbol of digi. Okay. Burnable, no, we don't want that. So now we're just going to create the interface. We're going to create the construct, and ultimately what we'll need to do is we'll need to actually mint tokens, right? With the 721, every token is unique. Everything has unique metadata, unique attributes. Hence, we can create these digital collectibles. We can use it to represent artwork. We could use it to represent real estate, etc. So again, when we mint it, it's going to be owned by this guy here. So this is going to deploy that contract, but it's not really going to have any state associated with it, other than the exception of this symbol, this name, and any attributes that we applied to it. Okay, so we can click into this contract, and then we'll just go ahead and mint the first token, and we'll let it be owned by the default account on node number 2. Okay, so click mint. We want to choose an index or a token ID. And then we need an endpoint to point to basically the representation of this non-fungible asset, some URL that has sort of the source of truth. So we'll just say example at endpoint.com. Okay, so we see the address, and this is the guy that's going to own it. And we're just going to mint it to ourselves. Who's going to find it? You are authorized for this transaction. Okay, that was a interesting false positive there, but nonetheless, we're good to go. So click node number 2, we can click his wallet, and we'll see the existence of a non-fungible ownership. And now what we want to do is out of band, we've understood that, hey, for 100 loyalty points, you can receive, some random digital collectible, right? Think of it as a basketball card or a representation of your favorite player on the team. I see we have a question in the chat, so let me just open that up real quickly. We add emoticons for ETH addresses in the Kaleido console. This really make my eyes bleed at the end of the day. Yeah, I mean, this is definitely something that is very, very easy to do in the interface, Frederick. So be happy to pass that along to our front end and user interface team. Okay, so we see that each of these default accounts has an asset. This guy has fungible, this guy has non-fungible, and we've brokered or we've structured that the semantics of that deal out of band. So now we need someone to actually initiate this transaction. Someone needs to be the creator of this, basically this hash locked contract, this swap, and someone needs to generate that secret and lock the contract with their asset inside of it. So we'll go ahead and do it with the organization that has the loyalty points. So we want to swap tokens. I'm going to hop out real quickly and confirm the address for who we're swapping with, which is this guy. So we're concerned with EC28. So back into the service, swap tokens. And we have a really, really useful interface that's going to guide you through basically the semantics of how this works, certain considerations that go into it, how you want the secret managed, how long you want these assets to be locked until they time out. So I am going to use the fungible assets. It's going to come from my wallet, and we've agreed that it's 100. Click next, and this is why I went and looked. I want to go to node number 2 that's owned by organization XYZ that actually has those digital collectibles. This is the end organization, the actual NBA team, for example. Set the timeout. How long do we want these to be locked before they're refundable, before they can be claimed if we don't both swap? We'll just do an hour. Choose how the secret is managed. Again, this is ultimately locked with the hash of the secret. So you can easily manage the secret, or you can delegate that responsibility, I guess that overhead, to Kaleido and just let Kaleido do it for you. Again, everything we're doing here is programmatical as well. And then you can send an email notification, optional, but probably a good practice here. So click deposit, and these fungible assets will get locked inside of that escrow smart contract here. And that will also start the timer on this HTLC. We've set it to an hour, okay? So the timer has started on this HTLC, and now the counterparty, the NBA team in our example here, is going to have a notification that a swap has been proposed. So we can go back, we can go into the token swap service for this organization, and we see that a swap has been proposed. 100 MBA fungible tokens have been offered. We know out of band that the response to that is to give a digital collectible a 721. So we can view the details, and we can now respond to that offer and choose to lock our own asset into this. One really important thing to take note of here is this timer. What is built into the product here, into the service, is a protection against the double spend. So we see that this is the ultimate timer for it. Once this asset gets locked in, once the counterparty locks in their asset, this timer is going to truncate by half so that the initiating organization doesn't have the ability to let it drop down to a few seconds, claim the counterparty's asset, and then the contract is completely open, completely unlocked, and they can refund or reclaim their own asset. So the classic double spend technique. So each party here is going to have an equitable amount of time to interact with this. Once we deposit this token, this will get divided by 2, and the fungible owner will only have that amount of time to pull out that digital collectible here. Okay, so we're going to go Digi, we're going to choose the wallet address that owns it, and then we need to put in the correct index here. So if I put in 0, it's not going to own that. If I put in 2, it's not going to own that. We own the first index in this 721 smart contract. So we'll deposit that. And now both of the assets are locked inside. Again, take note of this timer. When we go back to the interface for organization ABC, the guy that wants to pull out that digital collectible, we'll see that he's only going to have roughly 29 minutes to, follow through with that transaction. Okay, so 100 MBA for 1 Digi, it's ready to claim. So finally, we can go back in here. We see that this truncated in half, right? So that we don't have the ability to leverage or do something nefarious or malicious with a double spend technique. And then we can try to claim that offer. Again, everything we're doing here in the interface, you can do programmatically. I know I'm ad nauseum with that, but as we're building applications, we're using APIs, right? We're not going into an admin console typically and clicking around. We're creating our own experience for our clients and our end users. And these are all clean REST APIs, very easy to wrap your head around. So this guy's pulled that asset out, and now we can finally go ahead and take those fungible tokens as payment for our digital collectible. And we see that we have the full timer now, right? This party acted quickly, and now the asset is locked, only for the remainder of the timer. So we can claim that, and now we have an equitable trade here. So if you embed sort of those notifications, some event listeners, some email notifications, this becomes very easy to programmatically execute, complete these swaps here. So go back here, click on node number 1, and we'll see that this guy is now the owner of 100 less MBA tokens, and he's the owner of a digital collectible. Again, I encourage everyone to, if you're building out a solution, building out something with this approach, use the interface, use the console to wrap your head around the nuances, sort of the lower level or more esoteric features, and then just go ahead and use the Kaleido APIs to actually build out that service. Very easy to use, very easy to embed into an application here. And again, I'll just say it again, every single thing in the platform, there is an API for it, whether it's zero-knowledge proofs, whether it's configuring your environment, onboarding a member, allocating permissions, etc. There's an admin API, or there's a service API as well. Okay, no questions in the chat. All right, now for the more gnarly thing, zero-knowledge proofs. I will add the caveat that I am not a subject matter expert on Sigma bullets, on range proofs, on ZK snarks or zero knowledge proofs. We have a participant in the chat that does fit that description. So if you have any of those very, very low-level engineering technical questions, please pose those in the chat and you'll get a nice, accurate answer. I'm going to give a high-level walkthrough of how this works and sort of marry that with a real-world use case. So what we have here, and I should also add, if you do want, that low-level information, we have really, really robust documentation, kind of giving you a high-level overview, showing you how to use the service, and then actually explaining the nuances of, where this was derived from, what Sigma bullets and range proofs are, what a Zether smart contract is, etc. So let me set the table for ultimately what we're going to show, and then we can hop in and do it. So this is going to work for fungible tokens. So the use case we might want to, look at here is, we see some publicly visible transactions on chain, the exchange of, some non-fungible assets, right? We see some artwork exchange, we see some real estate exchanged, some batch supplies exchanged. We want to obscure the price for that though, and we want to basically do the fungible settlement for those assets completely anonymously, completely confidentially, and with the knowledge that no one's going to be able to derive or ascertain, who the sender and the receiver are, or even the amount that's being sent. And this is where the zero knowledge proofs come in. And so what happens is you have an existing ERC20 token smart contract, and you're going to create an equivalent of it. You're going to create a representation of it that we call a Zether smart contract. And this is going to hold encrypted balances, for public balances. What you do is for every Ethereum, every public Ethereum address or account, you can create basically a mirror of that. You can symmetrically create a shielded account. And those are the accounts that will live inside of this ZSC or this Zether smart contract. You can then use your public Ethereum accounts and you can fund those private or those shielded accounts. And those are going to hold now a Zether representation of your fungible token as an encrypted state. Subsequently, you can then transfer those to other wallets and other participants inside of this dark room, assuming they also have shielded accounts and they have a zero knowledge service. And then once you've obfuscated all of that trading, sent it around back and forth, settled your accounts, you can then withdraw any amount to any wallet that you want to, as long as the balance is held by a shielded account inside of here. So remember, every public account has a corresponding shielded account. We can get the balances into any of the shielded accounts we want, and then we can pull those back out into a public representation. So you can do some clever things in the sense of, put all the money in through a single account, disseminate it to a bunch of shielded accounts, and then over time extract it into other public accounts that never had that money to begin with. So it's very, very easy to kind of obfuscate and hide these transactions and do that confidential or anonymous darkroom trading. Okay, so that's my preamble of how it works. Now let's actually go take a look at it. So I have another environment here. I should also note that this only works with Quorum at the moment. So we have, again, our two memberships, our two organizations, Organization ABC, Organization XYZ. Since this is Istanbul, I've done 3 nodes instead of 2 like I did with Geth. And then similarly, we see some token factory services, some token swap services, and some ZKPs. What I'm going to do is I'm going to actually show our smart contract management feature, and I'm going to use that to instantiate just a trivial stable coin. And I'm going to give it to this guy's account right here. So 3BD1A. So I'm going to use our REST API gateway, and I'm going to create a smart contract project, and I'm going to instantiate an ERC20 contract. So back at our business network level here, we see this contract projects. And we've touched on this in the Wednesday walkthroughs, and we've touched on this in a handful of other webinars that we've done. But just as a reminder and for some muscle memory, we'll go this route again, since we just did the token factory as well. So we'll create a new contract project. We'll go ahead and call it stablecoin. We'll forego the description. And then we'll choose where we want this source code to come from. Do we want to link to a public or a private GitHub repository, basically the path to the Solidity file, or do we want to supply the bytecode and the corresponding ABI, the interface, so that we can build those REST APIs? I'm going to go the GitHub route because it's easier for me. And then I'm going to go to basically what I have here is a fork of OpenZeppelin. And this is just a simple token example here. It's going to be a stable coin here with a symbol of SC and a balance of 1,000. So I'll copy that link. I'll supply that to Kaleido. I'll give it a description, V1SC for stablecoin. It was only a single contract, so we're good there. This is public, so we're good there. And I'll let Kaleido auto-detect the rest. So basically, this is going to use a serverless function. It's going to take that endpoint, it's going to take that Solidity code, and it's going to generate us the ABI, the bytecode, and any dev docs that are sort of commented into that smart contract. So we see here the definitive path of where that source code came from. We even see the git commit hash. And this is wonderful for transparency and for collective oversight of exactly what you're executing on chain. What's the source? What's the provenance of this smart contract? So now I'm going to generate an API specification for this source code, basically RESTful representations of that ABI of all the methods that are inside of it. This is a ERC20, so there's going to be a burn and a transfer and a pause, nothing exciting. So I'm going to name our APIs. We call that the gateway API. And then I'm going to choose what environment I want to basically promote these APIs to. The idea here is that we created a contract project. And inside of that contract project, we had a compilation. Very rarely do you get the logic and the semantics and all of the nuances of your source code right the first time. It's a dynamic thing. It evolves and changes over time. So within that contract project, you can have multiple compilations. And this follows sort of those same DevOps rules where you would promote some source code into staging, into development. Once it's hardened, once your application is acting as expected, you can take that exact same definition and promote it to production, and nothing's going to change on your app side with the exception of an endpoint and some credentials, some TLS authentication credentials. So I'll send this to development, which is where we had all of those zero knowledge proof services. And this will build us that API specification, that gateway API. Gateway stablecoin, we don't have a live instance or a smart contract deployment of this yet. So what I can do is I can view the gateway API, can go into a Swagger console, and I can see all of the methods available for me inside of that ERC20, right? The transfer, the pause, etc. What I just want to do here is I want to use the root post method, and I want to give it to this account on node number 1. He'll be the owner of those 1,000 stable coins or SCs here. I'm also going to give this a friendly name rather than hexadecimal here. This is using our REST API gateway. So this is the abstraction of the Ethereum API, not making us use a Web3 client or a heavy SDK. There's no constructor. This is embedded into the smart contract, the balance. So I can literally just call the post method, and this will create an instance or an instantiation of that smart contract. So close this out. We're back on our gateway screen here, and we see we have a deployment or an instance in our nomenclature called stablecoin123. So hop back into my environment, click node number 1, click his wallet, that address, and we see 1,000 SC. Okay, what I'm now going to do is I'm going to transfer some of these to the account on node number 2 so that our other organization has some of this balance as well. So what I need is I need his address. So I'll go back here, this guy right here, and I want this user account. So I'm going to copy that. I'm going to go back into our gateway APIs. I'm going to go back into that instance, and I'm going to send this guy maybe half of those tokens. And again, this is really just an example of, how you can interact, using RESTful endpoints with, oh, that's the subscribe endpoint, sorry. I just want the classic transfer. We'll touch on the ability to consume events and create subscriptions in a different demo here. So this is the owner, and here's our params here. So we want the to address. We'll send it to what I have on my clipboard, and we'll send him half of the balance. So again, just explaining or trying to demonstrate how to use, a Swagger client inside of your Node application, and how to use basically these RESTful endpoints. So that transaction went through. So now we should sort of have an equitable dissemination of this, this stable coin that I created out of thin air. So node number 1, he should have 100 now on his wallet, or 500, excuse me. And this guy should have also have 500. Okay, and now we'll jump into the zero knowledge proofs, just so I have a sanity check and know that each of these actually have a balance here. Okay, so as we said at the beginning, the first thing we need to do is we need to take that stablecoin smart contract and we need to, quote unquote, shield it. We need to create a sister or a brother of it as a Zether smart contract. So that's the first action we're going to take. And either of these guys are going to be able to do that. They each own those tokens, so they're each going to be able to shield one of those. So I'll go into ABC here. And we see that we have the stable currency smart contract, and we want to shield the token. We want to create a Zether smart contract for it. I should note that this is brought to you by our Kaleido Labs team. So this is very, very cutting edge cryptography, really, really bleeding edge innovation stuff. So it's, we encourage everyone to use it. This is, an evolving construct. So we put it under our labs banner, just as a identification that this is really, really very much an emerging technology. Okay, so now we've shielded this smart contract. We now have a Zether smart contract for our stable coin. We see that we have 100 or 1,000 is the public or the total supply back over there in our public ledger, or ostensibly public ledger at this point, because we are in a permission network, and we don't have anything shielded. So now what we can do is we can shield an account. So we only have a single account on each node, and this is the one that actually owns that balance. So what I'll do is I'll shield this account, and this is going to create a corresponding account that lives inside of that ZSC that can receive or send back out those fungible or shielded tokens. So here's the public address, and here's now the shielded address. And we see it's a much, much longer string. If you're curious why that is, type it in the chat, and Amit or Jim Zhang will tell you exactly why. So we see that this account owns 500, again, ostensibly public stablecoins, and it has 0 shielded. So what we can do is we can now bring some of those public coins into this shielded account, have them represented as Zether, ZTH, just as a symbol. So we'll go ahead and click fund, and I'll just give them 250. We'll give them half of that, and we'll fund that Zether smart contract. Again, even all of this accomplishable with an API. So we see that we have a nice equitable split here. 250 shielded, 250 are public. And now we can choose to transfer those. This won't be very interesting because this is the only shielded account. So what we want to do now is I want to go into node number 2 or organization XYZ's instance of the service, and I want to do the same thing. I want to shield an account, and then I can choose to even fund it if I want to. So we'll hop out of here, go into this guy's instance of the service. The token has already been shielded. So all this guy needs to do is take his public account, the default account on node number 2, and he can create a mirror of that. He can create a shield of that. So just like we saw right there, here's the public address, here's the Zther smart contract address, and he's got 500 public and 0 shielded. So we'll go ahead and give him 250 as well. I see we have a couple questions. Open that up. Yeah, of course. I don't see a name associated with that anonymous attendee. But basically what you do as the user of Kaleido, as the builder of the application, you can abstract all of this complexity and you can build your own veneer, you can build your own interface on top of these APIs, and you can provide this behind the scenes, completely anonymous, confidential experience here. Okay, so we've shielded 2 accounts and we've funded each of those accounts with 250 ZTH. Now what we want to do is we want to actually do a transfer. Okay, these transfers are going to work by obscuring who the sender is, who the receiver is, and it's also going to be an encrypted representation of the amount. But you are going to know which parties are transacting. So that's what you get out of the box. You get privacy, but you don't get basically fully fledged anonymity until you do something else. So what we'll do first is we'll just do a normal transfer here. I'll go ahead and give node number 1 back 50 of these. So we're on XYZ. So I want to send this to ABC, and I want to send it to this shielded account. We'll give them 50 back. It's going to say proceed to add anonymity, and then it's going to tell me that, hey, something's not quite right here. And what this is saying is that if we add a handful of additional accounts, have the ability to send what we call decoy transactions. So you can send a null balance to a bunch of different addresses, and then through the beauty of zero-knowledge proofs and these Sigma protocols, you have the ability to essentially obscure. And the more shielded accounts you have, and the more transactions that are taking place, this basically increases that privacy and confidentiality exponentially. And we see here too that in order for the proof to be generated and the transaction to complete during a single epoch, Kaleido provides you with a convenient basically window where we are confident that this transaction, the proof will be generated and the transaction will be executed, that block will be mined. So there's a lot of gnarly things going on under the covers, with cryptography, with the generation of these proofs, with the verification of a transfer or of a burn of these shielded tokens. So there are time considerations that go into this. Okay, so we see that guy got his 50. There was a zero-knowledge proof where we obscured the amount. Both parties knew that it was going to be a positive balance at the end of the day. You can't send more than you actually have. And that was just private and confidential. What we want to do now is make it completely anonymous. So what we need to do is we need to go add some more accounts on these nodes. And we can do this one of 2 ways. We can create accounts directly on the node using the Kaleido API, or we can actually spin up a managed wallet service, an ETH wallet service, and create accounts through that service. I'm just going to do it right on the node for the sake of simplicity. So click on our wallet tab, add some new accounts, and we will increase our pool of shielded accounts and allow us to do a fully fledged anonymous transaction. So I'll create 4 additional ones for our friend organization ABC, and then I'll create a handful of additional ones for organization XYZ. So I think this should give us enough here. So now we'll hop back into the service and we'll start shielding those accounts. So we'll go to ABC first. We want to manage this Zther smart contract, and we see that we have a whole bunch of additional counts on node number 1. So I'm going to be patient and shield those one at a time. And I'm subsequently going to go do the same thing for node number 2, or organization XYZ's vision of this service. Okay. And now at this point, we should have the ability to populate that anonymous pool, those shielded accounts, and do a fully confidential, fully anonymous transaction here. This is the only guy that has a balance here, so we'll just initiate the transfer for him. We'll send it right back to that address right there. We'll give him 50 again and see if it allows us to add anonymity. And it does. So it just grabs randomly 6 of those shielded accounts that exist. Like I said, the more shielded accounts, you know, the vast exponential increase of anonymity that you'll have. So again, just like our original private confidential one, I'm going to make this private confidential and anonymous. So those are the 2 flavors of transfers that you can do within the ZKP service, within these shielded transfers here. And then the last thing we want to look at is actually pulling some of these shielded tokens out back into the public account here. Okay, so we see the real-time update. I'll go back to node number 1 and use that standard address that we were using the entire time. And we'll just pull out some arbitrary amount of those tokens. So I want to pull the accounts or the wallets, the tokens back into this guy, 3BD18. So this is the public one, this is the shielded one, and we'll see some representation of shielded tokens. So I sent him 50 twice, so his balance is up to, and I can withdraw any of those that I want. So he has, we'll just do the full allotment here. We'll take out 350. And again, this is going to generate a zero knowledge proof. This will be verified, you know, by a burned smart contract, and then those assets will be returned to our public Ethereum address that we can transact with as we see fit. So he had 500 left. Now he has 600 because we transferred 100 confidentially inside of this ecosystem. So click the wallet, click that, and we see that he went from 500 back up to 600 here. So that's kind of the way that it works within the console. Again, there's an API behind the scenes allowing you to, you know, interact with this programmatically, build your own interfaces on top of it, do key management on behalf of end users, you know, approaches like that. So not sure if there's any questions in the chat. We can also do interactive questions if you want to raise your hand. Okay, so just as a reminder for all folks on this, there is the ability to create a Kaleido account, experience some of these services on our free starter plan. We have a bunch of additional plans that kind of go hand in hand with the evolution of your project. So moving up to team, moving up to business, moving to enterprise. We work very closely with enterprises, but with businesses of all sizes, including startups. We have packages, you know, specifically catered towards smaller organizations or, you know, use cases, projects that are still in its infancy in the MVP, POC, pilot phase. I'm happy to share more information about any of that offline. I'm going to put my email into the chat. You can also, you know, contact us very, very easily from our website, Kaleido.io, support at Kaleido.io, help at Kaleido.io, or even use this drop-down contact us button inside of the platform for product assistance, to schedule a meeting, etc. So it looks like a couple comments came into the chat. I'll try to address those. Yeah, that's correct, David. I think there's a lot of different ways, you know, to do. We have a really rich ecosystem of additional services. For example, we have a document store service where you can take private storage. You can actually integrate, you know, with your existing, you know, cloud services, like for example, an AWS S3 bucket or an Azure Blob container, and you can securely reference, you know, off-chain private data, you know, with potentially some innocuous metadata on chain with just a hash of the payload to do transactions like that. This is really about the darkroom settlement of fungible assets. So anything monetarily, for example. I'll leave it to one of our protocol engineers to address your question, Peter. But this would be, I guess, an abstraction or a removal, a second layer off of what would, I keep using the word ostensible, but in this I'm using our private permission Kaleido environment as ostensibly our public environment. And then within that, we can take a step kind of down the rabbit hole into this dark room, and we can do those zero knowledge transactions, only putting the proof, the representation of that on chain, something that's completely indiscernible to anyone looking at it, but that each counterparty is able to, prove and verify. Okay. So again, we have really, really comprehensive docs on both the swaps and the zero knowledge proofs. There's a really, really great academic blog that's been written by two of our engineers. You can, find that by just going to our blogs page and look at the technical blogs. It's aptly titled Zero Knowledge Proofs, so it's very, very easy to find. It's either on the first page or the second page. And this will actually kind of expound on a lot of those lower level details that I was stumbling my way through. But with full transparency, I'm not an expert on layer 2 range proofs, sigma bullets, etc. Okay, looks like one more question. Yeah, we can share that with you, of course, David. Peter, I believe that is the case. Again, I really would love Amit or Jim to chime in if either of you are still on this, to basically give some unequivocal response to you. But yes, that is sort of the idea of zero knowledge proofs, right? Is that there is this cryptographic representation or proof that these assets were settled, that there was a positive balance from one party, that there was a received balance from the other party. There's other techniques as well to basically provide evidence of the transaction and to keep the vast majority of plain text data off the chain. For example, that notion of just putting a hash pointer onto the chain and then taking an event off the chain. So Amit, I'll leave this open for a couple more minutes if you want to respond to Peter. Peter, if you do want more information, please ping us inside of the console or at support or help at kaleido.io or me directly, and we'll get everything answered for you. So I'm going to give it 1 or 2 more minutes inside of the chat, and then we'll go ahead and call this a wrap. If for the folks that are still on, it would be really helpful for us if you kind of want to articulate some other topics that you're interested in. For example, key management, event streams, storage integrations, identity management, integration with OpenID systems. There's a lot of functionality inside of the platform, so we'd be happy to dive into any, and eventually we will dive into all of it, but based on requests, we can prioritize as well. And you can also share that information via email, via our help desk system, or via some of those contact us mediums that I just explained. So thanks everyone so much for attending. I hope this was enlightening a bit. Key management, I didn't, okay, that's awesome, Marijo. So that's definitely something that we can do. EA privacy extensions for sure, Frederick. We can use Quorum and Hyperledger Besu, talk about trusted compute. Yeah, these are great topics. So keep an eye out for key management and basically user-based JWT authentication with embedded rules. That's a new feature that we just released. It's really, really nifty. So with that, we're gonna call this a wrap here. Thanks everyone for attending. Thanks for the very engaged questions. We will do these every Tuesday for the foreseeable future. And if you are new to Kaleido, maybe tune in tomorrow as well, where we'll do just kind of the 101 level stuff of creating a network, creating an environment, doing some basic transactions. We'll go a little slower than we went today with kind of these more involved services. So thanks again, everyone. Hope you stay safe and healthy, and we will talk to you soon.